Hey guys, I just wanted to come on and do a couple of these problems from this 2-1 worksheet, the sum different factoring. So if you take a look at the front, hopefully these aren't too bad. You'll notice that there's some 4 terms that you need to factor by grouping, some quadratic patterns. There is a video on this from earlier in the week, so if you need a refresher on how to do any of those, I would go back a couple days and check out those factoring videos. On the back, though, I thought maybe I would do out maybe 1 or 2 of these, just because although you know the factoring pattern, you may not have seen it kind of done out quite like this. So if we take a look at just number 7 here, well, if x minus 3, see how I have an x minus 3 squared there and x minus 3 to the first term there? So this would look like a normal quadratic if x minus 3 was just something else. So what I like to do is just take that binomial right there and just set it equal to some other variable like w. Okay, so w is x minus 3, so I can rewrite this equation like this. Do you see that? Isn't that the same thing if w is, substituting in for x minus 3? And now this is a quadratic like we've factored 1,000 times, so that I can very easily factor. Okay, so now I can solve for w. W has to equal positive 5 or negative 1, right? Now, I'm not quite done, though, because remember, I'm trying to solve for x, not w. So I'm just going to go back to that substitution right there. If w were 5, it'd be equal to x minus 3, which means that x would equal 8. And if w were negative 1, and that were equal to x minus 3, that means add 3 to both sides, that 2 would be equal to x. Okay? And so there's my 2 answers for x. You can always plug them back in and check them. And you'll kind of do the same thing in number 10. I would just take 2x minus 1 and set it equal to w, or, whatever variable you want to use. Okay? And then you actually kind of play the same game when you look at 11. So this looks super complicated and hard, but I'm going to do sort of the same idea. Now notice, it's always that middle term. That x minus 3 is what I set equal to w. So I am going to do the same thing for this one. I'm going to take the square root of x and set it equal to w. So when I rewrite this quadratic, it's going to look like this. You see that? So now I have this, and I can solve it like I always do. So factors of 8 that have to be 6 would be 4 and 2. Solve each one. That means w is going to equal negative 4 or negative 2. So now I go right back to this. And negative 4 is equal to the square root of x. And negative 2 is equal to the square root of x. But I have a problem right here. There is no number whose square root is negative 4. Remember, when it's written this way, right, there's no negative on the outside. You're always taking the principal square root, right? So I can't plug in a number. I know you're thinking, well, 16 square root is positive and negative 4. That's true, but this is only a principal root, so I only want the positive. Okay, so what does that mean? That means that this particular problem doesn't have a solution. And furthermore, think about when you are solving a quadratic, what is it you're really finding? Aren't you really finding where this thing crosses the x-axis? So real quick, I'm just going to pop this into my graphic calculator, and let's just see what this quadratic looks like. Just give me 1 second here. Okay, So let's see. Oh, good. It shows up pretty nicely. So there it is in my calculator. And then let's see where this thing crosses the x-axis. My prediction is that it never does because I got no solution there. So if I hit graph, oh, you'll see, and you can zoom out a little bit. Yeah, this thing does not cross the x-axis, so it makes sense that I got no solution there. Cool. Okay. So no solution on that one. Now I will tell you that number 9, there was a little typo, so I fixed it on your sheet. I hope you can read it. That -2 on the end should just be a +4. This one does have a solution. Okay, so when you try that one, make sure that it comes out nice. All right, that's it for this. See you guys later.